Hello, everyone. In this lesson, I'm going to talk about how to find tangent line, normal line at a given point. In our circumstances that we're usually given a point a comma f of a, and this is, can also be called x naught comma y naught or x0, y0. The point slope formula would be if we know the slope. Okay, if we know the slope, suppose this, m is the slope of tangent line. Okay, so here I'm going to mark m is the slope of tangent line. And that tangent line in this picture will be the purple. And this tangent line touches the curve at exactly 1 point. That's the slope. And the blue is the normal. Normal line is perpendicular to the tangent line. Okay, so it's the slope of normal line. That's the m perpendicular of a normal line. If we know either one of the slope, if we know the slope of m, which is a tangent line, then we can find the line equation. In our case, that would be y0 would be f of a, and x of 0 will be a. For normal line, we just use the slope of the normal line. Then what's the relationship between the slope of tangent line and the slope of the normal line? These two, if we multiply them, it equals to -1. That is to say, okay, the slope of the normal line is the negative reciprocal of the tangent line. So if you know one, you will find the other. Okay, and it's also true that if you know the slope of the normal line, then you will be able to find the slope of the tangent line. So that's their relationship. Once you know one, and you can know the other. And this formula will be the one that I use most often. As you can see, this is the general instruction about the general guideline for how to find tangent line and how to find normal line. The next question will be, how can we find the slope of tangent line? To find the slope of tangent line, I would like to talk about there are, in general, three ways, okay? Or really 2 ways, okay? The first way will be the way we just learned. Take one example, okay? Take one for example. We can use any one of the 3 to find the slope of tangent line. Say, for example, using the first way or the second way. The first way and the second way are pretty common. And the third way or the first way, they can be seen as using formula, okay? So I'm going to explain it to you how, okay? The first way, okay? In the first way, so how to find slope, right? So this is how to find slope of tangent line, okay? So the first way is using the definition of derivative, okay? Definition of derivative. Okay, and of course the definition of derivative, we have all these 3 different forms. Okay, we did not use the form in the middle. Since someone asked, so I will explain it to you. Okay, and the third way, we haven't done that very much, and I'm going to explain all these 3 different ways. The first way for this particular example at 0.34 would be that we're going to find, suppose this is equal to f of x. Okay, suppose this is equals to f of x. So what we're going to do is that we're going to, take the function and we're going to plug in a, right? So every x will be replaced by a. And we're also going to replace x by a plus h. So every x will be replaced by a plus h. Okay, so then we're going to plug in the formula. Okay, we're going to plug in the formula. And of course, for this one, we're going to, expand, right? So let's do some expanding. Okay, so let's get into the action. And follow me, please. So we got a squared plus 2ah plus h squared. In our case, our a is 3. Okay, so we're going to put in 3 there. Okay, we're going to put in 3 there. Putting 3 there, 3 in place. So this will be 3, right? So this is going to be 3 squared, 2 times 3a, 6h. Okay. And all the a's are substituted by 3 plus minus negative 5 times 3, that's minus 15, minus 5h plus 1. Okay, so let me double check. 3 squared plus 6h plus h squared. And then we're going to expand further. So that's going to be 3 squared is 9. Okay, so this will make 18. We're distributing. So 12h plus 2h squared. Remove this minus. I'm sorry. So we're going to put it here, combining like terms. Okay, combining like terms, we will have 18. Let's just be patient. Okay, so these are not very difficult to do, but we have to be patient to get it right. Okay, so 2h squared, and we have plus 7h, plus 7h, negative 15 plus 1, that's negative 14. Okay, negative 14 plus 18, that's a plus 4. Okay, let me just double check. Okay, that's correct. Simplify f of 3. Okay, that's going to be 2 times. That's equal. That's going to be equal. That's going to be equals to 2 times 9 minus 15 plus 1. Okay, 2 times 9, that's 18. Okay, so 18 minus 15 plus 1, that's a 4. Okay, so by this time, we're going to do the subtraction. Okay, that's f of 3 plus h. That's I'm gonna do minus f of 3. So this is 3 plus h. So put these two expressions together. Minus 4, right? F of 3 is 4. And then we will end up with 2h squared plus 7h. And then we're going to divide and take limit. Okay, so we got our 3 plus h, 3. And that limit will be it becomes more concrete, right? So because we've done the top is that piece. And the next step is H is going to be reduced. So we will end up with, that's equal. Wait a second. Okay, that's okay. So it's 2H plus 7. Okay, 2H plus 7. And direct substitution, we're going to get 7. Okay, because H will be substituted by 0. Okay, so now we got the slope. Okay, we got the slope. This slope, we also call it f prime of 3 equals to. Okay, so notation wise, you know that this is the slope at 3 for the tangent line. So this is the slope. So this is also the slope of tangent line. And that slope is a derivative of the function at 3, which equals to 7. Then what will be the slope of the normal line? The slope of the normal line would be the negative reciprocal. So it's negative 1/7. Okay, so by this time we can find the line equation now. We can find the line equation, okay? So we're going to take these two formula for line equation. And we have the point. The point is 3, 4, right? So that's the point. Okay, the point is 3, 4. So f of a is 4, right? F of a is 4. And a is 3. A is 3. And the slope, and this is 7. And this is negative 1/7. So we have found our tangent line. So this is tangent line at the point, right, at 3, 4. And this is the other one, and this is a normal line at the same point at 3, 4. So we're done. The disadvantage of this method is that every time you have another point, you will have to go through the whole process all over again. Okay. For example, if I choose a different point, say if I choose not 3, 4, I'm going to choose 0, 1, right? 0, 1. So I choose a equals 0, then you have to do another round. If I choose a equals to say -2, then you have to do it all over again. Okay, but that's how the process works. Okay, so this is one way to find slope using the derivative formula. Okay, the other way, which I like to mention today, because some people ask about it, so why couldn't we use that formula? You could, okay? So for example, in our case, if a equals to 3, okay, still for the same point, we can find the slope, right? And our f of x, instead of doing f of 3 plus h, we would just keep the f of 3 equals to 4. Okay, f of 3 equals to 4. And we're also going to take the f of x, right? We're going to take f of x, okay? Then we're going to compose this limit. To compose that limit, you're going to be taking f of x will be substituted by this piece. F of a will be substituted by 4, okay? And the denominator a will be substituted by 3. Okay, so we are looking at this limit, and of course we're going to organize our term a little bit. Okay, that equal sign. 2x squared minus 5x plus 1. 1 and negative 4 will combine into negative 3, and we will factor. We will factor because we cannot do direct substitution. And a is 3, right? So x approaching a equals to 3. Okay, so let's factor this. We are getting, okay, so let's factor the numerator. You can factor any way you want. And what I got is this, x minus 3 on the top multiply 2x plus 1. Okay, and the denominator is x minus 3. X minus 3 and x minus 3 will be reduced. Okay, so let me go down a little bit. So now we're reducing x minus 3, which equals to just 2x plus 1. 2x plus 1. Direct substitution, you should also get 7. You get the same number, and then you can go about to do what you need to do. So the first two formula can be used to find slope at a given point. Okay, let's look at the third formula. Okay, the third formula, we will say it will get us the derivative. Okay, let me put these two together. Okay, the first one and the third one. The first one and the third one. Okay, without actually plugging in the value a. Okay, so we do everything symbolic. Okay, we do everything symbolic. So this time I'm going to be doing the latter formula. Okay, I'm gonna be doing this formula. Okay. What I would do is that what does this do? This would derive something called derivative function. Derivative function is basically a formula for derivative. A formula for derivative. So what we will have here for this particular case is that we're going to put our function in place, right? So f of x plus h, right? So we're going to have, I'm going to bring f of x over, and f of x plus h. So everywhere x will be replaced by f of x plus h. Okay? And then we're going to take all of these. So you see, we didn't substitute x by any particular number. So I'm just going to put these quantities in place. F of x is over here. Let me put a bracket here. Okay, so we're going to operate with respect to x to find this, to basically find the formula for any slope. Okay, let's see how we're going to finish up this part of simplifying. Okay, so let's first make this 5 minus 5x minus 5h. I'm just going to reduce it slowly. Okay, follow me. And this negative sign will be distributed to each term inside the bracket. So this will turn to plus, and this will be turning into minus. Okay, we're going to wait a little before we get to this piece. Okay. 5x and 5x will be reduced. Plus 1 minus 1 will be reduced. So this will be gone. Negative 5x, positive 5x. So we have a minus 5h, right? So we have minus 5h here. So now I'm going to do the reduction. I'm going to do the reduction. So I'm going to, of course, expand it, right? So I'm going to expand it. That's going to give me x squared plus 2xh plus h squared. Sorry, squared. And then distributing the 2, we will get, put the 2 to multiply each piece. So this will make 4, and this will be 2. Remove the bracket, you can see 2x squared and 2x squared will be reduced. Okay, so negative 2x squared takes away the positive 2x squared. So we get to this point. With this point, right, and we're going to factor out the h. Okay, h is factored out. So we get factored out the h. So this is gone. And one of the h is gone, and this is gone. So after reduction, taking limit as h approaching 0, so this h is reduced, this h is reduced. Okay, so we'll be left with this piece. Boom. Direct substitution, we got 4x minus 5. 4x minus 5. This is the formula. This is the formula for derivative. What does it mean? It means that if you give me any number, for x, I will be able to find the slope of the tangent line passing that point. For example, for f of 3, right, we were considering, in early on, our point is 3, 4, right? It's because 3, 4. So for 3, 4, so if we have 3, so I replace x by 3, I will be getting the slope 7. If you give me another value, right, you say, oh, I want to get 0. Well, at 0, it's going to be negative 5. If you want the slope for point 10, so I'm going to replace x by 10. So this way, you don't have to do the whole process all over again. So this is the good news about using the formula. Okay. So this is the third way of using these 3 formula on derivatives. And the first formula, if you don't use any specific value for a, it plays the same role as this piece. What I meant is that if you do f of a plus, if you do this, okay, you just don't do the you do, instead of doing these, right, using x, you just do a without substituting a by any specific number. So you just do this, right? If you just do this, you would also get a formula. You would also get formula for which is similar to what we just did. Okay, so you can put all of these over inside the formula and use this piece as your f of a, right? Remember what we just did. And this piece will be similar to what we did over here. Okay, so you would get the same formula, which is going to be 4a minus 5. Okay, so 4a minus 5. You can try this because I think you understand what I'm saying. So we're going to proceed, right? So you're going to get 4a minus 5. So once again, that we have found the derivative of the function at a, which is 4a minus 5. If I know a equals to 3, in our case, so that will be 3. So it's the same process. And you also get 7, and you can do substitutions like these. So that's the advantage of having a derivative function. Okay, that's the advantage of the derivative function. So we have talked about all these different ways to find the slope of a tangent line. Okay, number 1 is to use the formula with a being given as a numerical value, or the second way with a given as a specific value, the third way, and the first one with a not replaced by any concrete number, it gives us a formula, right? Give us formula so we can get derivative at any point, and also as a consequence, we will get the slope of tangent line at any given point without having to do the formula all over again. Now, last way we're going to talk about today is using derivative formula. Derivative law, okay? Derivative law basically allow us to find derivative using derivative law. For example, for this particular function, we can find the derivative. And that derivative, f prime, is going to be 2 times 2x, right, minus 5. And that is a 4x minus 5, which is the same formula here and the same formula there. And from there, we will be able to find the derivative of any number. So if I want to find the derivative at 3, and I will just, plug in 4 times 3 minus 5, I will also get 7. So these are the, I would say, 3 or 4 ways to find the slope of tangent line. So once you find the slope of tangent line, and we would know what to do, whether you want the, whether you want the equation of tangent line, or you want the equation of the normal line, you can find them all the same. Okay, I hope this will help, and I try to make it short. And so this summarizes all these ways that we can find the slope of tangent line. The next question is, which way do you need to know? Okay, you need to know, of course, this way. Okay, then you see that's a pretty easy way. But also, for the purpose of midterm exam, you need to know this way. Okay, you need to know this way, which is to derive formula. And thirdly, you need to know how to find that using this method. Okay, so you need to know all 3 ways to do it. And if you want to use this other way, that's okay if I do not specify. If I do specify which formula you need to use, then you should use that method to get the credit. Okay, I hope that's enough information for this short lesson. Thank you for watching.